All right, we have talked about now several different factoring strategies. We've talked about factoring out of GCF. We've talked about factoring by grouping. We've talked about using the special sum difference of cubes and difference of squares. And we've talked about factoring that are quadratic in form, okay? So we are going to have to mix these all together and be able to choose what strategy we want to use. So here's sort of the question tree that you want to go down. So first question is always, is there a GCF? That we have to remember. And then we look at what's left, and we want to decide based on how many terms it has. So if it only has 2 terms, we want to look, is it a difference of squares? Is it a difference of cubes? Or is it a sum of cubes? Remember that the sum of squares is prime. That's not factorable. If it has 3 terms, we want to look if it is quadratic in form. So what is u equal? What's that middle term? That's what you're trying to decide so you can factor. And if it has 4 terms, we're going to use factoring by grouping. Okay. Now, we have been factoring with the goal of being able to use it to solve polynomial equations or to find the zeros of a polynomial function. So remember, if we're going to solve, and this is the same strategy as with quadratics, we need to first make sure the polynomial is equal to 0 because we want to be able to set those factors equal to 0. Then we'll factor it, if it's possible, using a strategy that is appropriate. And then the last thing is we're going to apply the zero product property, which means set each factor equal to 0. If the factor is quadratic, then you can either factor it, square root it, complete the square or quadratic formula as needed. You might get imaginary solutions, and that's okay. We're going to count those as solutions. So you might get some real number solutions, you might get some imaginary number solutions. So let's try a couple and see where we get. So, number 17. First, I need it to be equal to 0. It is. Then we look for a GCF, and this one does have a GCF. I can divide everything by x. So let's start by factoring that out. X times x squared minus x minus 20 equals 0. Do not lose your equal sign. That is critically important. Okay. Now we look at what's left inside, and it is quadratic. So I'm going to say what multiplies to 20 and adds to -1. It's going to be -5 and +4, and this is an a equals 1 shortcut. So we get x times x minus 5 times x plus 4 equals 0. And so now, and you can do this step in your head, but remember what we're doing is we're setting each factor equal to 0. So where does x equal 0? Where does x minus 5 equal 0? And where does x plus 4 equal 0? And so the solutions we get are x equals 0. That one's done. Add 5 to both sides. X equals 5. Subtract 4 from both sides. X equals -4. 3 solutions. Okay? Let's look at number 18. First thing, it is not equal to 0. So let's subtract everything to the left and put it in standard form order. So I have x cubed. I'm going to subtract x squared from both sides, so that makes it minus x squared. Next would come minus 7x, and then I'm going to subtract 7 from both sides, so I get minus 7 equals 0. Do not forget your equals 0. Okay, is there a GCF? No. Now we look at the terms. I have 4 terms. So what strategy should we use? Factor by grouping. So let's factor what we've got. X squared times x minus 1 minus 7. Hold on. Is that right? Minus 7x minus 7x plus 1. Let's change this to a minus 7 right here, and that makes this a plus 7, because otherwise this is not going to be factorable. I think that's a typo. So if we factor out a -7, I get x minus 1. Now we get that common factor, which we want. And so I get x minus 1 times x squared minus 7 equals 0. Now here is where we have to do a little bit of work. This first one is pretty easy. We're going to get x equals 1 as our solution. But this second one is not quite as obvious. I need to know where x squared minus 7 equals 0. and that's not a difference of squares. It's not factorable, but I can use square roots because it just has x squared. So I'm going to add 7 to both sides, and then I'm going to take the square root. Remember that when we do that, we always get 2 solutions, plus or minus the square root of 7. And so altogether, we really have 3 solutions to this equation. X equals 1, x equals positive square root of 7, and x equals negative square root of 7. So these answers are not all going to come out nicely when we have to deal with square roots and stuff like that. Okay. Let's look at 2 more. Number 19. We need it first to be equal to 0, and then we're going to check for a GCF. Go ahead and pause and try that step on your own. All right, so we should be 2 here. And now we look, we have a quadratic inside, and so now we're going to look, can I factor this? Does anything multiply to -4 and add to +6? And the answer is no. Does that mean we're done? No, it doesn't, because we can solve quadratic equations. So the zero product property, we're going to take 2x squared and set it equal to 0. And we're going to take x squared plus 6x minus 4, and we're going to set it equal to 0. So this one's easy, x equals 0. There's one solution. This next one, not quite as nice. So I cannot use square roots because there's an x squared and an x. But this is a great one for complete the square because a is equal to 1 and b is an even number. So that's what I'm going to do. X squared plus 6x plus blank, and then add the 4 over plus blank. So half of 6 is 3, and 3 squared is 9. So that's what we're going to put in the blank. And this factors to x plus 3 squared equals 13. You could also use quadratic formula on this. I just prefer complete the square if I can do it. Then we square root both sides. X plus 3 equals plus or minus the square root of 13, and then subtract 3. So x equals -3 plus or minus the square root of 13. That's our other 2 solutions. Okay. Number 20 is already equal to 0. There is no GCF, so now we need to look. How many terms does this have? It has 2. So we need to check, is it a difference of squares, difference of cubes, or a sum of cubes? X to the 4th is an even number, which means it is a perfect square. And lucky for us, 9 is also a perfect square. So that's how this is going to work. This is x squared squared minus 3 squared. So this factors to x squared plus 3, x squared minus 3 equals 0. So we have 2 quadratic factors. Neither one can be factored more, so we're just going to have to solve those 2 equations. X squared plus 3 equals 0, and x squared minus 3 equals 0. So go ahead and pause your video and try those yourself. So we're going to start by subtracting 3. So x squared equals -3. We're going to get imaginary solutions on this one. Square root both sides. X equals plus or minus I root 3. There's 2 solutions. Here we add 3 to both sides, square root. So x equals plus or minus the square root of 3. We get 4 solutions altogether. 2 are imaginary and 2 are real. So the most important thing here is this tree right here, okay? So it's always based on how many terms. 2 terms, something special. 3 terms, quadratic or quadratic in form. 4 terms, factor by grouping. Keep that in mind with every single problem. That's how we solve a polynomial using factoring.